Okay, today we're going to look at some word questions involving factored form of the quadratic equation. Let's face it, we know some of us have been asking, why exactly are we learning this stuff? What's the point? It very much depends on what you're going to end up doing down the line. Okay, some careers use parabolas a lot. Some careers you never see parabolas again. It sort of depends on what pathway you are going to end up following career-wise. You chose to do the course. I'm required to teach as part of the course, so you're going to learn it because it's in the course. Footballs kicked through the air. The height was recorded on the table below. Find the equation that models the data. So we haven't been given a whole lot of tables this way, but we still have the same information. Here we have an x-intercept. Come on, write. Why aren't you writing? 10. So here we have an x, here we have an x, and I know that because its height is 0. So if I were to graph this out real quick, it's going to look like that. At 0 and at 4, I have my x-intercepts. And then at this point, I have my vertex. Okay? Not necessary to know, but, always good to, that with parabolas, we're going to end up asking for the vertex sooner or later. Now, what we do need right now is an equation in vertex format, factored form. And at the point, that is what the equation is. So we're going to sub in what we know. We know that our first intercept is at 0. And we know that our second intercept is at 4. Now, had I been thinking, or had I been aware, I could have just jumped directly to AX, bracket x minus 4. It was delivered on my behalf, whether you believe me or not, that's a whole other issue. But I wanted to show you what you do with a value of 0 and how it relates to the equation. We have seen it before, but it's one of those things that does tend to get people a little messed up. Now, we need to use one other point in order to finish off our equation. Doesn't matter which point, we could use 1, 2, or 3. I'm going to choose to use the vertex just because I'm that kind of guy. So what it means is that our formula is going to look like this. Oops, sorry, that last one should be a 4. Now, eventually you're going to have to get used to, instead of a y, it's going to be an h, and instead of an x, it's going to be, in this case, a t for time, which is actually how most of these types of equations are written out. Not a whole lot new compared to what we've done. Do we know the max height? Yes, we do. Do we know the zeros? Yep. And it lands at 4. So we know our individual values. Yeah. Unfortunately, they're not. So for instance, this time we have a golf ball that's flying through the air. La, 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 la. And we're trying to see if we can figure out what an equation of best fit is. Now, if you notice, these values are a little odd. They don't go up by the same amount every time. So it's a little harder for us to tell what kind of graph this is. Now, we could use the logic, hey, it's in the parabola section of the course, it must be a parabola. But in real life, we can't do that. So best thing to do is to graph your data and give yourself an idea of what you're looking at. In this case, if we were to take the data and graph it, it does in fact look like it's a parabola, which makes sense. You will learn that anything that flies through the air without rocket system to it, so not an airplane or something like that, but a baseball, moves in a parabola. Now, how are we going to get that second x-intercept? Somehow we need our graph to come down here. But how are we going to get that second version, second value? We could estimate it. I've just randomly drawn it and no accuracy whatsoever. I've just done it really quickly, and it looks to be about 125 meters. Meters? Yes, 125 meters. There's another way. If you look at the pattern, assuming this is our vertex, the 30 and the 80 are roughly the same distance apart. The 30 and the 90, check it out, their values are about the same. So since this is a difference of 30, what if we extended this 30? We could reasonably say that that's 0. It's not going to be precise, no matter what we're estimating one way or the other. But I think that in this case, using the table to kind of get a rough idea makes for a better value. So this time we're using that trick from the first time, since we know we start at 0, 0. We have x minus 0 or x plus 0, which is just x. And we're going to pick another point on the graph. It's not going to be precise. No matter which point we choose, they're all going to give us slightly different answers. But the idea is to get an estimate. So I'm going to choose the one in the middle, the 60, precisely because it is in the middle. It'll be a little bit off of the 30, it'll be a little bit off of the 80, but it should hopefully be between the two values. It's not perfect logic, but it's not bad. A So here we have 30 divided by, sorry, negative 30 divided by 3,600. Remember, you can move that negative sign around wherever you want. Zeros cancel out. I know that 3 goes into 36 12 times, and since I got that 0 hanging around, means I can now rewrite my equation. And be reasonably assured that it's pretty accurate. Dufferin Gate is a parabolic arch that is approximately 20 meters tall and 22 meters wide. So we're going to sketch a graph of the arch. Oh, is it on the next page? Hey, look at that. 20 meters tall and oh, whatever. So I'm being lazy here. And it's going to look something like that. Now, if you're being told to graph it and it's for March, you should really do a much better job than what I did. But as a organization of thoughts, that's pretty good. Now, I've cheated. I've used software in order to graph this. And if you're able to, based on that information, great. But we actually don't have enough information that we can do this. So we have to approach it like the last question. I don't know how, I wonder how I managed to get that graph. That's kind of cool. Oh, I know how I did it. The advantage of knowing how to use Desmos. Anyways, so if we look at it as being, if we move that center line over, it means that this distance over here is 11, this distance over here is negative 11, right? We're kind of looking at it as that question from the other day, with total distance of 22 all around. We've already got this up here, which means we got ourselves, oops, a pretty little vertex. So now we're back just a stereotypical problem. We know our vertex is here. That was neat. That's still neat. Cool. There is no number that goes in the 20 and 121, so we can just simply write it out the way it is. All right. Now, the one thing that I was a bit of a bad boy about with all this is that we got to define our variables. And I haven't done it in any of the questions, and we're going to here. Of course, I've left myself no room to do it. And y is the height, also in meters. And there you have it, how you turn real life examples into parabolas.